Okay, in this video I'm going to be talking about how we can find the percentage yield in a chemical reaction. So in this sort of question you'll be given a amount of product which has been produced in a reaction experimentally. For example, in this case we have 30 grams of copper being produced from a certain quantity of reagent, in this case 25 grams of aluminium. The first thing that you'll need to do in this sort of reaction is to balance the chemical equation. So here we have copper phosphate reacting with aluminium. Now we know that aluminium is a more reactive metal than copper, so we know that aluminium is going to be able to reduce the copper and displace it out of its compound. And from the question, we already know that we will be producing copper as one of our products. The other product that we will be making, since the copper is being reduced, is going to be the phosphate of the aluminium, since the aluminium is going to have to be oxidized in order to reduce the copper. Now, we know that the phosphate ion has a 3 negative charge. From this, we can work out that since there are 2 phosphate ions, adding up to a total of 6 minus here on the right-hand side, the copper, since there are 3 of them, each of them must be 2 plus, since they have to cancel out the 6 minus of the 2 phosphates with 6 positives on the 3 coppers. Aluminium is in group 3 on the periodic table, so we know that aluminium will form a 3 plus ion. So we know that the product, aluminium phosphate, is going to have 1 aluminium to 1 phosphate, since we have the aluminium 3 plus and the PO4 3 minus. Now this equation is not yet balanced. We need to make sure we have the same number of everything on each side of the reaction. So in the copper phosphate we have 3 atoms of copper. So we must make sure that we have 3 atoms of copper here on the right. Now since these are individual atoms over here, we put the 3 as a coefficient in front. Also in the copper phosphate we see that we have 2 phosphate ions. In the aluminium phosphate we only have 1 phosphate ion. Now we cannot put the phosphate in brackets here as we did before, since that would alter the balance of the electrons between the aluminium and the phosphate. So if we need to have 2 phosphates here on the right, we have to put a coefficient of 2 in front to give us our 2 aluminium phosphates, therefore our 2 phosphate ions on the right hand side. Now since we are using 2 aluminiums, or producing 2 aluminiums here on the right, we must be using 2 aluminiums here on the left. So now we have fully balanced our chemical reaction. Now, the information that we're given in the question here is that we have 25 grams of aluminium to start with. So we can already say that we know we've got 25 grams of aluminium. From this 25 grams of aluminium, we can deduce the theoretical yield, the quantity of product that we should make if the reaction was to run perfectly. Now to do this, we first need to work out the moles of the product that we're going to make. So from our 25 grams of aluminium, we can work out how many moles of aluminium that equates to. So 25 grams of aluminium divided by the atomic mass of aluminium, which is 27, which we can find in the periodic table, gives us 0.926 moles of aluminium. Now once we know the moles of one substance in a chemical equation, we can use the ratios of the coefficients to find the moles of every other substance in the equation, since the coefficients tell us the ratio of each substance to each other. So 2 atoms of aluminium will react with 1 molecule of copper phosphate to produce 3 atoms of copper and 2 molecules of aluminium phosphate. Therefore, if we have 1 mole of aluminium, because of the 2 to 3 ratio, we would be producing 1.5 moles of copper. We don't quite have 1 mole, so what we need to do is we need to take our moles of aluminium and apply this 2 to 3 ratio. So the easiest way to do this is to divide the 0.926 by 2 and then multiply it by the coefficient that we're interested in, so by 3, and that will give us 1.39 moles of copper being produced. And we could do the same for our other substances as well. Since we have 2 aluminiums and 2 aluminium phosphates, the number of moles of the aluminium phosphate here is going to be exactly the same, so 0.926, and the number of moles of the copper phosphate we started with will be exactly half of the aluminiums, so 0.463. But we're not actually interested in these substances, so we're not going to be using those in this question. Now, once we have the moles of the product that we're interested in, we can now determine the theoretical yield, the mass that we should produce. And again, we can do this by using our atomic mass of our copper, which is 64, We can multiply the number of moles by the atomic mass to give us our theoretical yield. So 1.39 times 64 gives us 88.9 grams of copper as our theoretical yield in this reaction. Now, the theoretical yield is the quantity of product that we should make if the reaction was to be run perfectly. As we're told in the question, in an experiment we only produce 30 grams of copper. Therefore, we can now work out the percentage yield that this is of the theoretical yield. So the percentage yield is the experimental and we multiply it by 100 to give us a percentage. So in this case, we can take our experimental yield of 30 grams, we can divide it by our theoretical yield of 88.9 grams, and this will give us a percentage of 33.75%. So this reaction, the experiment, produced 33.75% of the copper that we would expect, theoretically, if the reaction was to have run perfectly.